special episode straight from CodeBeam Europe in Berlin. I'm Lars Wikman, and I have two very special guests to introduce. So first, the creator of Elixir and Chief Adoption Officer at Dashbit. So give a warm round of applause and a warm welcome to José Valim.
Thank you.
And then we come to the person that we all use to convince other people to use Elixir, the author of Elixir in Action, and the person and speaker who showed us the soul of Erlang and Elixir. Another warm round of applause and warm welcome to Saša Jurić.
Thank you.
It's a pleasure to have you both back on the show. Very welcome.
Thank you for having us.
Thank you for coming. So the topic that I wanted to take on when I had the opportunity to kind of pick both of your brains is kind of what remains. Where could we go in the future? Because Elixir and Phoenix has taken what Erlang has built up and kind of pushed it further and explored it more fully. Like we thoroughly exploit the near real-time facilities. We use the concurrency heavily. We do a bunch of message passing, all good stuff. Like we have things like live dashboard that start to use the introspection and observability. We have things like Broadway that kind of push the Beam functionality, like the things that the Beam can do forward, and kind of make them more accessible to people, more easy to use, more capable. What are next steps? What are parts of the Beam? Because the Beam can do a ton. And what are parts that we are not fully exploiting yet, not fully utilizing? Where do you think the community should explore and go and build further?
You want to take it?
Yeah, just a straight answer would be nice.
I have a cop-out answer, which is it's really like you're asking the wrong person. Maybe Saša is the answer, but what I always say is that like Elixir was designed to be extensible, and being extensible on top of a great platform, as you're pointing out, it was a good choice. And so it means that anybody can get Elixir and expand it to whatever domain, to whatever area they want. And so for me, like, who needs to answer this question? It's like the 400 people here in this room. Like, you are the one who says, like, here's where I want to take it next. Because if you were to ask me, like, 10 years ago, I would never have come up with nerves, for example. I would never say, like, oh, Elixir is going to be good for embedded software, because it's not because, it isn't. It's just because it's not something that I think about or worry about. I wouldn't have thought about Membrane and using Elixir and Erlang to build these, like, audio-video processing pipelines. And when you look at it, it's like, oh, yeah, it makes a lot of sense, but it's not something where my mind is at. And yeah, so I'll start giving the hot potato to Saša, and then we can circle back.
Well, thank you so much. So yeah, what he said, but no, I mean there is definitely sense in that what you said, José, that like users or people who basically use the language should take it in various directions, and really there have been some unusual stuff, like when I think about what was the state 10 years ago, so that's really cool. So that being said, from my point of view, I definitely see a lot of room for improvement in like this ops space, so to speak, where we, so like these days I hear from people saying that like Elixir is kind of like a Kubernetes at the language level. Back when I was starting with Beam, with Erlang, then the saying was that Erlang is an OS for your code, and I think that like these are basically the same statements. And so whatever we typically fall back on to the OS level or to the Kubernetes level, for example, is to me the question, why don't we do it in the language, right? Because that makes many things simpler. So like the foundational pieces are most certainly there. So we can do, this distributed programming and whatnot. But when it comes to anything similar to what we have in Kubernetes, like if I wanted to say, like, I have a couple of Erlang nodes, and they all run the same code, for example. And so I want to, like, have some services or some, gen servers, if you will, that, some smartness is going to be spreading those things around and, starting and stopping them depending on the load patterns and whatnot. That's basically, just requires a lot of manual re-implementation, right? So we're kind of missing those higher level things, which I think could be very, very useful and which could simplify development in many cases. Because for me, it's always like, what does it take to build a system, to take it to production and build like a production-ready system independent of like the domain, of the business domain, or even the scale or complexity. And so these days, it still takes, in my view, too many technologies and too many things need to be learned, and we need too many different experts in different areas to get there. And
the table could have more rows, right?
Yes, precisely.
So for those who are not aware, Saša, in his book, he wrote a table comparing Erlang with other technologies, and the table pretty much goes like, oh, web server. And in one column, it's like, so we have one row, web server, and then one column says, in Erlang, you use Erlang, and then in another stack, you're going to use Ruby.
Yeah.
And then if you have like, in-memory cache, and then for the Erlang column, the answer is still Erlang, and then in the other technology, you would say Redis, right? And then what else do you have on the table?
Well, there was the reverse proxy thing, right? So in many cases that I've had, we just use stock, either back then was Carbo, it was Phoenix. By the way, just to make it clear, this is a true story, that table. How many people did read that book and seen that table? So yeah. So it's a true story. It's not a contrived story, right? So like I was working on these two things side by side, and when it hit me, like how much we have to improvise in the land of, and it's not about Ruby, it's about pretty much any non-Beam language, how much we had to improvise around some stuff that was lacking in the foundation, and how much was there, in Erlang back in the day, in Elixir as well, or Gleam, any other language, then it hit me, that's when I went all in for Beam, I never looked back again, yeah. So that table can definitely be expanded. I think there's like a lot of room for improvement there. That's a lot of hard work, though. But I would wish to see taking us in that direction. At one event I spoke, I think it was prior to pandemic, that like I would like to see an SQL database written in a Beam language, right? So something that like think about what it takes today to use an SQL database. Like you have to manage like Postgres or whatever you're using somewhere on the side. And then you have to deal with the impedance mismatch, which is always like takes a lot of like you worked on Ecto a lot, right? So how much effort was done on just mapping the types, for example, right? And just managing this thing on the side. So like, what if I could have an SQL database which I just start link somewhere in the supervision tree? It doesn't have to be like super scalable or be super fast, but for many needs, I think this could be a nice start. And like we have these 15 minutes demos. I would like to see a 15-minute demo that just builds a full production together with ops and everything in Erlang, Elixir, Gleam, in like 15 minutes without anything else. Just mix new, and adds a few dependencies and just starts a few processes and it works like production ready. I think that would be cool.
And maybe it may take a little bit of thinking out of the box as well. Maybe it's not even a SQL database, but a database that is designed differently to best leverage all the properties that we have from the virtual machine at the runtime. I think can definitely be interesting, and people from the audience who work on the database area, they may have like better ideas of what designs would particularly excel or Erlang and Elixir. Yeah,
I think there's a talk during this conference on
there are two talks actually,
but on moving amnesia towards self-recovering from splits and stuff. So yeah, because amnesia seems like an obvious thing to pick up, but it certainly has its challenges as well. It's not quite so plug and play if you run into problems.
But Ninja gives you kind of like this idea when you think about it. You know, you start Ninja as an embedded database in your application code, right? And so, disregarding a bunch of practical challenges that you have with Ninja, especially in distributed environment, like it gives you like key value storage with persistence and transactions and distribution, which has some room for improvements, and many people have kind of sunk trying to fix that. So maybe we're going to see some better approaches. But I think that like the general strategical idea of Ninja is what I like. Like here's your embedded database, that you can use, like without having to run something on the side, and it's concurrent, and it has all the bells and whistles that you have with Beam, right?
Yeah. Something I've seen also in the ecosystem is that we put a bunch of work in to kind of make sure that we are on the level of other ecosystems when it comes to observability, like OpenTelemetry, having metrics, traces, logging, like that makes sense. But I also know that the Beam is much more introspectable and observable than many other systems. Are there things you would like to see people explore there? I know Thomas Depierre released Orion, which is like this distributed tracing profiler that can give you a histogram of the timings for calling functions across your cluster, and it's like a web UI that just plug into Phoenix and go. So that's something I find interesting, and I think it would be essentially impossible to do in many other languages.
I think so. When it comes to observation, I think one of the things that I've been part of the Erlang community for 12, 13 years, and I've always found like really nice examples and applications of like taking the observability that the Beam offers and doing something like mind-blowing with it. I remember, I think it was a demo from Michał Śląski. I think it was called Erlang Performance Lab. At the time, Netflix came with this visualization of how like traffic is flowing through their nodes, because imagine that if you're operating at Netflix scale, you have so many nodes, so they come up with this whole visualization system of how like a network is going through their nodes and so on, so they could visualize and understand it. And then Michał was like, oh, sure, I can do the same for Erlang and Elixir. And he had a demo where you had all of the processes, and you could see the messages flowing through the processes. And I think, and I can think of other things that I've saw, but I cannot describe them with such precision. And I think one of the interesting things here is that it's great that the Erlang virtual machine allows for exploration, but also that I think there is kind of a question of like why those projects, they come up and they are short-lived, right? Because they are like, and I'm not saying short-lived like I'm not giving any reason, but I think it's something that is worth reflecting because, and I think that's something that OpenTelemetry can help address, because if you have a standard that everybody's using, because if you think about a large system, like you see this nice visualization, you have to run in production, you have to figure out all the mechanisms to run that. And so I think what I'm trying to say is that when we go into the discussions of like, oh, what are the cool things that we like to see on the Beam? And there is always the side of like, oh, we can build this really cool thing, but you also have to find like what is the practical use case for this thing, or how can you plug that into allow people to plug that into production systems, so it will actually be useful for a longer period of time. And I'm not saying that what they did was useless, but I'm saying it's like it needs to be part of the problem solving, right? It's like, we can do all this cool stuff, but if we can't easily allow teams to put that in their dashboard or whatever they are using, it's not necessarily going to help. And that's where OTel helps, because we just need to export the data out of the Erlang virtual machine, and there are now dozens, probably more than dozens of companies that can receive that data and show that in interesting ways. And we need to continue going in that trend.
Yeah, I think it's an absolutely kind of critical baseline to have, like to work with those standards and do everything that the other ecosystems do. But I'm curious if we can push that further. I see potential in, for example, the Erlang tracing facilities are strangely, impressively capable. And for debugging a specific issue, that type of deal, where you want to dig into production code, ideally without shipping new updates. I think the tracing has a lot of potential there.
It is. I think we're kind of in a good place when it comes to that. So the foundations are terrific, and you know, since the release of Fred Herbert's Recon, which was like, I don't know, that there's already many years since that was released, it's typically quite straightforward to use it in production. Visualization, as José mentioned, are nice. You know, there were like a couple of these projects. I remember that there was one called Ruby that did like a three-dimensional, I think, view of the processes and dynamical view of everything that was happening. But like those are nice. But I agree that you know, most probably in most cases, just exporting to a well-known standardized format makes more sense. Yeah.
Yeah, and it's another area. It's like not only tracing. It's like just the tools that are in the Erlang virtual machine is amazing. So. There is a module called instrument, I believe, that comes in OTP. Has anybody used the instrument module? All right, like 4 or 5 hands.
Yeah, that's like 1%.
One of them is from the OTP team, so it's kind of like... yeah, so... and somebody reached out to me. They're like, you know, we have this problem, like the memory usage is blowing up, and we don't know where it's coming from. And then I went like to tools, because there is an application in Erlang that lists everything that it uses to instrument and find things in the system, tools or runtime tools. And I found this module there, and then it was like, well, it just kind of prints a diagram. It just gives you information of where memory is being allocated in NIFs. So they were like, we suspect it's a NIF because we cannot find it like in the usual ways where you're going to inspect the process. So we suspect it's a NIF. And then I'm like, okay, let me see what are the tools that I have. Like, and then I go to the Erlang documentation. There are like 5, 6, 7 different modules, and then like there's this instrument module. And I'm like, okay, what is this? And like, oh, it shows how memory is being allocated inside NIFs. And then I was like, and it's a function. It's just a function call that you do. It's like you call this function, or maybe you call a function to start measuring, another to stop. Very easy API. I was like, all right, like have you tried this module? Connect to your node, run this. So I sent an email, and then like 15 minutes they come back later. Oh, here are the results. Apparently we have this NIF that is leaking memory, and we just replace it for another solution, another NIF, and the problem disappear. So it was like, it was a 1 hour of email exchange for something they were like really not knowing how to address that problem. And the problem was solved. They're like, okay, we know what it is. We'll use another solution next. And I think it's a great example of just like the tooling that is there. So one of the things that maybe somebody wants to even provide a pull request, because we have the Phoenix Live dashboard that comes with Phoenix applications. And I want to have a button there where you say, please instrument my NIFs, and then you're just going to press this button, and we're going to plot this graph for you. And people now I don't even have to tell them, like, go to your remote shell. Just like, go to your dashboard, press that button, and come back to me.
Does that button exist, or do you want?
No, yeah. If somebody, I think we have an open issue.
Okay.
He's fishing for a pull request. Yeah.
It will exist in a week.
Nice one.
Yeah.
But that's kind of where I would see, like, a small tracing utility for just digging in.
As well, yeah. Where you could just set on like the trace of your code per some criteria or something.
Observer
like that.
comes with tracing as well, right?
Yeah.
I believe, yeah.
Okay. Yeah. And profiling as well, for example. I used to have those cases too. You know, like, I just want to profile these bits of code or something like that. So there's like a bunch of improvements that could, or extensions that could be done.
Yeah, and on this note, I'm almost sure that Erlang OTP 27 is also going to come with a heap profiler.
Okay.
So now you can also profile memory usage. So
cool.
It was a contribution from Max from WhatsApp, so it's really nice.
Saša, you were going into the deployment and ops side, and whenever I talk to someone who's not doing Elixir, not doing Erlang, about Elixir and Erlang, and they've heard of it, the first thing they say is hot code updates.
Oh, yeah.
Does that have a place in this future deployment scenario?
Yeah, hot code updates are like, you know, I think that many of us who are like have been in there long enough, in Erlang land, they would say like don't use hot code updates. That's like a typical advice, and I feel sorry that we have that kind of advice because it's such a powerful tool, but it is difficult to do it at such a granular level, right? So that's like super fine grained. That probably you don't need something like that. But what if we could find some kind of a middle level, where I could just say, I'm going to push new updates, and I just want to restart some larger part of my supervision tree rather than dealing with all these updates of state of the gen server and something like that. And so then you have more like kind of like a microservices style of deployment where you just have push the new version of the code and restarted something without restarting everything, and you don't have to reason about state changes and things like that as much, right? So I think that like all the building pieces are there. Basically, you can do this with a custom, update script, but you just are lacking some kind of higher level, easy-to-use interface that you could use to make it happen. I think that's like a nice thing to explore. I was going to do this at some point, but just never managed to find the time. Yeah, if someone wants to pick it up, ping me after this talk.
Yeah, I agree with exploring something like that. It can be interesting, and I think it's also like if you don't use the capability being there, it means that you can build things on top. So I remember, like I think it was on the first Elixir conference ever. One of my favorite talks was from a company that they had like online poker game, right? And the thing is that now imagine that you want to upgrade your software that is running production, right? It happens that the games, they last very long. They can last very long. And it happens that people are playing poker all the time. So it's like there's like no time where you can say, oh, you're going to stop like your game in the middle so we can like upgrade your code, right? Like the game is live all the time. And it's a live game, so it's not, so they use all the infrastructure that the Erlang virtual machine has to implement their own version of deployment, which is like, well, if this game is running, we are going to transfer the game to a new node. We are going to keep them in sync, and we are going to tell the players to migrate, and everything works transparently. But they use the foundations that were there for their specific use case to solve that problem. So that's a fun anecdote that I wanted to share. But there is also, I have a minor gripe with whenever people they are talking about like something like hot code upgrades, for example, or like using Erlang in the context of Kubernetes. They're like, well, like what is the point of using Erlang if I cannot do hot code upgrades, or if nobody's using hot code upgrades, and I dislike that because it's like it's saying you're not going to use Erlang for something that it has, but you chose not to use, and nobody has that. So you're not getting that anyway. It's like saying, I don't want you to give me a Ferrari because the roads I live nearby can only drive 100 kilometers per hour maximum. It's like, it doesn't make sense, right? So it's like, I think I like to say, in the worst case scenario, you're going to deploy Erlang and Elixir like you deploy any other technology. You can totally do that, right? And the fact that you're not using the extra features that Erlang has and nobody has should not count as a detriment to Erlang or Elixir. It's kind of, it's not logical.
It's also like it's not like you're not going to use any of the goodies of the Beam, right? People that just focus on like one thing, and it's like, yeah.
And you still have a lot to use. You still have the concurrency. You still have the functional programming model, right? You still have, as we're talking, all the introspection that you have into the system. There's still a lot to use.
Yeah. Precisely.
I've talked to Frank Hunleth of Nerves, and he says one of his fastest iteration processes is just pasting modules into IEX. It's like, oh, I have it running on device, something's wrong, I need to switch out this little bit of code. All right, paste the new module, just straight over SSH, it's fine, because we can do that. Actually, how many have pasted code into production?
Production.
Yeah.
Some hands went down, but most stayed up.
All right, yeah. Let's. 3 hands went up, right? 3 hands.
Now people do this, right? I mean, that demo, how many have seen the Soul of Erlang and Elixir talk, Okay, so there are like some people, and there's like this demo where I kind of connect to the system and trace it, and then do a live upgrade just by pushing some, and that's like the true story actually, So it's just of course a dumbed down version, but it's literally what happened. Production was hanging, and like it happened during the weekend, and like the whole weekend we weren't aware of it, and I was debugging this on like Monday morning. Nobody was complaining really, things were working fine. And I was debugging this, and then I just tested the hypothesis by doing the hot upgrade, even though we didn't do it anyway, and I don't suggest it, but I just did this, and this is like you still have that option. That's the point, right? Even though you don't necessarily use it regularly, right?
Yeah, no, and there's the other thing. Like people are saying like, oh, but we don't use hot code upgrades. And I was like, are you sure? Because every time you're using Phoenix in development, and the code just upgrades when you do a new request.
Precisely.
That's using hot code upgrades, and that's using something that comes with the VM. And other communities, the amount of work they need to do to get that same thing, it's a solve a problem there, but it's all additional tooling, additional complexity that exists around it.
And it frequently it's just an approximation of what we get. Yeah. It's basically the Robert Wording's first rule. I forgot exactly how it goes, but like any concurrent, sufficiently complicated concurrent program in other languages is like an informal, bug-ridden, ad hoc implementation of half Erlang, something like that.
Yeah.
I think we're approaching the end of our time, and I think that's a pretty good note to end on. Thank you so much, both of you, for joining me on this, and we'll catch you next time on Beam Radio.
Thanks.
Thank you.